All right. Let's take a look at this. This is going to be our very last page of notes. Little too excited about that. Just saying. So this is number 8 in the notes packet. It's the very, very last one. So first things first, we need to figure out what shape this is going to be. What's it going to look like? A rose. This is going to be a rose. How about if I write an R?
What's your favorite one?
To do or to graph or the look? I like the roses. I think they're the prettiest. I was gonna say calculation wise they are the hardest. They're just lengthier. Ooh.
Two petals. Wait.
Hang on. I was say, look, what's our N?
2.
N is 2, which is even.
Wait, no, that's 4 petals.
4 petals. All right, y'all, my turn to talk. Thank you. If you're answering my questions, that's fine, but the alternate conversations, not as much. So we know N is even, which means we're going to have 2 times N petals. So we are going to have 4 petals on this flower. Yes, so our period length is going to be 2 pi. So we have to do the whole circle on this one. Yes, dear? Because if we, boop. On our roses, we look at our N. If N is even, our period length is going to be 2 pi, and we have 2 times N petals. It's going to make an even, matchy kind of set like this. Our odd ones, so this one is what an even one looks like. The odd flowers wind up asymmetrical, so they get an odd number of petals. The even ones have an even number of petals, so they double up. So we're going to have 4 petals because our N is 2. So we also know, because of this, our period length, we are going to do the whole, all the way up to 2 pi. So you could come here and just straight up plug, chug, go all the way from 0 to 2 pi. Every angle in between, plug them all in, go through that. It's good practice for us to try the other way, though. So you could come down here and we could just straight up do our 0 and our pi over 6 and our pi over 4 and our pi over 3 and our pi over 2. All the way across, doing all these pieces. And we're going to fill them all in anyway, so it doesn't hurt to fill those in. But we're going to do the method we used for the rose yesterday to find our maximums and minimums. Because 1, it's good practice for us of old skills. And 2, it fills in like 8 values in the table in one go. Which we love. We love a shortcut. So we'll have all our values down here. The highest we can get on the cosine part is 1. Yes. But is cosine the only thing that's relating to our R?
I don't know.
Because there's the 3 multiplied in front. Yeah. So I'm just going to fill in all our values over here. Because we totally could come down here, plug, chug, and get the exact same answers. It would work. It's just going to take you an hour and a half to fill in all these pieces and type them all in and switch them to decimal and all those things. I just put the wrong denominator because that's 5 pi over 4. And then our 4 pi over 3. 3 pi over 2. We're almost all the way around. 5 pi over 3. 7 pi over 4. 11 pi over 6. 2 pi. So those are all of our unit circle values, all of our radians. And again, we'll get the exact same things if I take each one of those, plug and chug, and switch them to decimals. But I want us to practice the other way because, oh no, we have a final coming up in, a week and a half. So thinking about this in the other way, our maximum value. We know the highest value we're going to get on this cosine portion is 1. So what is the biggest our R value can be? 3. Because we have 3 times our cosine, which the highest we can get that cosine to be is 1. So the maximum value is going to be 3. So the farthest out our radius is going to be is 3. Whether it's going positive 3 or negative 3, that is the farthest away from the center it can be. So our max values are going to occur when this guy equals 1. So when cosine of 2 theta equals 1 is where we're going to have a maximum. It's also going to happen when our cosine of 2 theta equals negative 1. Because we're dealing with polars here, it means that's the radius. It's how far from the center. So that's also going to be a maximum. So we're going to solve both of these. I know it's going to zoom things weird. So if we have cosine of 2 theta equals 1, how can we solve that? Yeah, we can do a u substitution here. Cosine of u equals 1. It's a lot easier to think about u. So what angles would give a cosine of 1?
0 and pi.
So 0 gives us a cosine of 1,
Oh,
but pi gives us a cosine of negative 1.
that was a prank. I meant
So
2 pi.
plus our 2 pi n, because it happens every time it goes around the circle.
Wait, so when it's odd, it would be plus pi. When it's even, it would be plus 2 pi.
When it's the 1 and negative 1, that's when we're going to have our 2 pi n's, because it has to go all the way around the circle. If we're looking at our zeros, since that doesn't matter what sign it is, we can use the pi n. So let's look at, we switched our 2 theta to be a u, so this is actually that 2 theta equals 0 plus 2 pi n. So what's our theta going to be? Yeah, 0 plus pi n. So it'll occur at 0, pi, 2 pi, and we could keep going, but we know that's where we're stopping on our interval anyway. So if our cosine of 2 theta equals 1, we know our radius is going to be 3, because 3 times our cosine of 2 theta. So these 3 values are going to have a 3. So we could come down to our table, since we already have filled that in. 0 is going to have a radius of 3. Pi is going to have a radius of 3. And 2 pi is going to have a radius of 3. So we've got 3 values in our table right there. Same kind of vibe on this guy, on our negatives. Same process even. We can do our cosine of u equals negative 1. So what's our angle? Pi. And it repeats every circle around, 2 pi n. So if we know 2 theta equals this, pi plus 2 pi n. Am I hearing a question mark? I couldn't tell if I was hearing a, Okay. So say, if you got a question, I'm happy to answer. But it's kind of like when a sim gets lost and they're just sitting there going, No, it's okay. Well, you call anybody out individually. What's up?
So it's better going to be pi over 2 plus pi.
Yep. So our theta is going to be pi over 2 plus pi n. So when we have our pi over 2 or our 3 pi over 2 or 5 pi over 2, but that's outside our interval. So this does keep going, but we don't need any more values than that. And so for these two pieces, this happens when our cosine is -1. So if this chunk is -1, what's our radius going to be? -3. So these ones have a -3 as our radius. It still counts as like a maximum. -3 on this one, -3 on that one. Because if we think about our points, I'm just going to sketch these up here. If I'm just going to look at pi over 2. This is not where these dots are going. If I have a radius of +3 and a radius of -3, don't draw these in. Just me showing you a thing. They're both maximums on these flower petals. Okay? Oh, that is really skinny. So they would both be maximums out here, whether it's a +3 or a -3. That's why they both count as maxes, even though one's positive and one's negative. Everything's looking at that distance from the center. So then let's look at our zeros, because that's going to fill in a bunch of other places in here. So we're going to do that same kind of vibe. We're going to look at our cosine of 2 theta. And we want to know when that equals 0. And again, you can approach this the exact same way we did the other ones with that u substitution. So if we know that cosine of u equals 0, what's our u going to be? Pi over 2? Yeah, because it's happening at pi over 2 and at 3 pi over 2, and then again 5 pi over 2, and then again at 7 pi over 2. So it's repeating every pi n. Whenever we have the zeros, it's going to be that pi n, but it's pretty much only going to be on the zeros. But again, we can switch that back into our 2 theta, because we know that 2 theta is actually going to equal that pi over 2 plus pi n. So what's our theta going to be? Plus pi over 2 n. So our zeros are going to happen at pi over 4 and 3 pi over 4 and 5 pi over 4 and 7 pi over 4. And it could keep going. It would happen at 9 pi over 4 and 11 pi over 4 and all those other places. But these are the only ones that fit on our graph. So these are all going to have a cosine that equals 0. So 3 times 0 is still going to be 0. So all of our over 4s are our zeros. And we have more than half of our table filled in. And then we can plug and chug with the others. We're going to take our 3 cosine of 2 theta. I'm going to write it down here just because it's too small if I zoom out that far. Random and underage minor child. Careful what we say.
What did you say?
Talking about beverages that we do not know the flavors of yet.
Yeah, we don't know the flavor of Vanessa.
Yeah.
Minor child.
Yeah.
This is what I'm talking about. Some people
Filter between your brain and your mouth. Use it. No, it should not be 3 because 3 is our maximum. So think about our, no, be nice, be nice, be nice. 3 times cosine of 2 times pi over 6. So that's the same thing as 3 times the cosine of pi over 3. It's going to be 3 times 1/2 because cosine of pi over 3, unit circle value, it's 1/2. So 3 times 1/2, 3 halves or 1.5.
And then negative 1.5?
Yes.
And then positive 1.5?
No.
Wait, how are you getting 1.5? You're getting 3. You're just wrong all the
You
time.
just substitute.
Are you in radian mode?
Okay.
Be nice. Make sure you're in radian mode if you're typing in the calculator. You don't need a calculator for this one because the cosine of pi over 3, that's a unit circle value. Cosine of pi over 3 is 1/2. That's why we use unit circle values, is we don't technically need a calculator with it because there was a very long time you didn't get a calculator in this class, period. It's going to be negative 1.5.
Wasn't last year like this course with the auto calculator at all?
I was going to say, it's this. This is the first year we've known the whole year that you could use a calculator. They told us last year at the very, very end that they were changing it. So like we used to have to do all of this unit circle values in our heads. Okay, so be grateful. So I was gonna say we're gonna keep going through them. So with our pi over 3, that was giving us cosine of 2 pi over 3. Cosine of 2 pi over 3 is also a unit circle. That is our negative 1/2. So we need our 3 times the negative 1/2. So when we do 2 times 2 pi over 3, that is 4 pi over 3. Cosine of 4 pi over 3 is also negative 1/2. So we're still on our negative 1.5 here.
Oh, and then we go to 1.5.
And then we go to our positive
And then
1.5.
we go 1.5 and then negative 1.5 and then negative 1.5.
It's almost like it's very periodic and things are very cyclical. And we're going to have very similar values in a lot of places. Be careful about finding patterns and then just going boom
Yeah.
down that path. So make sure we're double checking things.
I like shortcuts.
Shortcuts are lovely as long as we follow them carefully.
I'm scared that she's gonna say
Don't go driving off into the middle of the woods.
I think that's-
Follow the path
I'm gonna let her drive home.
and then
Did you
no
hear what
caution.
she said?
But that's
She
not.
said something very nice.
No, I didn't.
so we should get our positive 1.5 for 5 pi over 6 and a positive 1.5 for 7 pi over 6
And then negative 1.5.
and then a negative 1.5
And then negative 1.5. And then a 1.5.
and then we're at the end. And it would loop around. I could keep going and do our 13 pi over 6 as a positive 1.5, which would be exactly the same as what pi over 6 is. Because 13 pi over 6 is coterminal. So it loops around. So let's plot up our points carefully. I was looking through our points homework. I have a lot of people that got really confused with the negatives, so be super duper careful. So our 0, radius 3, we're on angle 0, radius 3. It's going to be out here. So looking at this guy. Pi over 6 means we're on this angle here, and our 1.5 is right here. And I'm going to switch this to be our red. Hang on a second, because I want this to be the same color as the number I put. Then we have our 0, which is right in the middle. So, and if you want to, once we hit zeros, sometimes it's easier to connect it up before we go on to more places, since the 0 is going to be used a bunch of times. So sometimes it's easier to connect it every time we hit a 0. That's a thing that works really good for my brain. That is not a thing you have to do. I just find it really easy when you hit a 0, connect that piece up because we headed to an entirely separate segment. So that was our pi over 4. So now we're going to do our pi over 3. That's this angle here. Negative 1.5. Think of this like a line. We are going negative, which means we need to go down this way. We stay on that same line. So our negative 1.5 is here for pi over 3. So this is that point. Well, we got to stay on our pi over 3. That's this guy. Hang on, it's going to
Wouldn't it be like on the bottom?
No.
I can't see. Can you
Okay.
move?
So think of our pi over 3 as a straight up line.
Yeah.
So if I need to go from positive 1.5 down to negative, I need to stay on this line.
Yeah.
So it's gotta be down here on this side. This is our pi over 3. It's gotta be on this side. It's one line that goes to the center. So our angles count as lines. Do not bend it at the 0. This is not what we're doing. Straight lines.
Well, like, not like bend it, like stay on the line and like go down a little bit. Like, 1, 2. Oh! Oh!
There we go. Got you. I was just saying we're making sure we're connecting the same place. Cool, cool.
Silly little Justin.
That's okay.
I was looking at the x-axis.
Don't say my name
Like, I
when
was
it
like,
comes to doing.
Think of it as our radius.
ah.
All right. So then let's do our.
That's what we did the first day.
It's okay. It's been several days, and sometimes it takes working with it to connect it. So then we have our pi over 2 that has a -3. So we're going to go 1, 2, 3. Pi over 2 down here. And then we have a -1.5 on our 2 pi over 3. 2 pi over 3 is this guy. So it's going to be down here. And then we have another 0. So I'm going to connect them up because I know it's going to connect from here. Red point, pink point, red point, back to 0. Because that's where we found out. We started with a 0. We ended with a 0 on that pedal. So that was this pedal. So then we're doing our 5 pi over 6. That's this guy. With our positive 1.5, that's over here, this one. Then pi has a radius of 3, so we're out here. And our 4 pi over 3. Or, nope, 7 pi over 6. There we go. That's the one. 7 pi over 6 is the next one. Right there. And then we get another 0. So we go and do another connecting piece. So finish plotting them up. We should get with our -3 looking like
Wait, lower.
it shouldn't be. I'm good at counting is what that is. That was me thinking and talking at the same time. So it should be out like that. And then our last point is going to be there. And it will loop around. And we have our flower. We have our rose that has 1, 2, 3, and 4 petals. I like the flower ones. They're pretty. Okay. So we're going to talk about the project. I'm going to show you a couple of things that we can do on the computer that's going to make it a little easier to do the project part. So I'm going to show you a couple of things on Desmos before I hand out the thing. So I have a couple of pages up here. So this is points. I just wanted to give us a chance to look at things. If we are, ignore what's written on this side. This is just for the sliders. Looking at our point, and it's giving this address here. So if we had a radius of, 3, and our angle, it's going to be weird and decimally, but it's jumping around that circle. It's going by pi over 12s. You can play with these and see the different points. So if we're at pi, which is going to be 3.14, we can see our radius being positive 5, 6, 7, 8 versus negative. If I do there's my, 5 pi over 4 is what that one is. Radius of -3 brings it out. Radius of farther negative brings it out this way. Positive brings it this way. So looking at this is what's going on with our points here. So if we're at 0, here's our radiuses. Here is all these pieces. So for those of us that were struggling with the points, this one might be a good one to work with. And I can put these up on the Canvas page so you can play with them if you want to. Looking at our graphs, I want to show you what it looks like when we're plotting these up. It makes a difference how we plot them. Let's see, I mean, look at this, thicker, there we go. So the red line is tracing the graph. It makes a difference when we're plotting them in order that we connect the points in order. So we can do this and kind of see all these pieces connecting and tracing to make the graph. And we can do that with flowers as well, with the roses. And I'm going to switch this to be a rose real quick. So if we did 2 cosine with, let's do a lot of petals. Let's do maybe, that's what I was thinking. So let's do, so we know if it has an n of 4, we've got even, and so it should have 8 petals. When we connect that up, it's going to loop through it like this. So it draws it kind of like an old school star, and it's going to loop through. So if I want to make that bigger on a radius, hang on, ignore the middle part, that's just that it's tracing it. So it traces it in this same kind of pattern. So when we're working on this and when we're working on the project, be careful with our roses, because if we go with too many of the petals, letting it loop. Nope, pause. So if I, instead of doing 4, did something like 8. Totally doable. It's fine. But look at where our maximums are. Hang on, I'm going to turn off the animation because that's just being annoying right now. Pause. Go away. We have like maximums in between pi over 6 and 0. We have one at pi over 4, in between pi over 3 and pi over 2. So there's a lot of weird places for this. Even if I was to do something like 6, we wind up with our maximums on our pi over 6 and pi over 3, zeros in between every single one of these. So this is when we would want to do this with our maximums and minimums, because we have so many of them. When we have as few as we did before with our 2, it's a lot easier to see that, oh, that's what's happening here. But if we get a bunch of them, it's going to make it weird. So if we do something like 7, things are going to wind up weird and decimally. So that's when it would be really helpful to do it as maximums and minimums for all those pieces. So what we're going to do for the project, and I'm going to pass out the information about this, is you guys are going to be making, there's the page, one of this page. You guys are going to be making these kinds of things. And I have some, so everyone can see, these kind of foam boards. Those are polar graphs just stacked on top of each other. I have the foam, I have the pins, I have the string. So like, we'll be fine, supplies are, you don't have to bring anything. And colors. This is muddy.
Colors of 3?
2. Groups of 2. So I'm going to pass this out. This does include in it the rubric on how it's being graded, so we know exactly what's going on. Okay, so you will graph no less than 4 polars on there. There are different point values based on the difficulty of the graph. So you can get some extra credit on this too if we do a little harder equations. So we have opportunities for that. This does go into the quiz category. So for those of us that need a little boozy in that little quiz category, this is a great option. So what I want you to do today is you're going to figure out who you're working with, your partner, and you need to start planning what your design looks like. Don't just go in willy-nilly on this. So, still watching me, I highly recommend that what you guys do today is we go on Desmos and kind of make a plan on what we want to do. Because what we need, because included in here is we need our tables typed on there. Because you have to include on the graphs your tables. They're on the back. So I need your tables. And I need your equations. So like the equations are written up here. This was before we had the typing situation. So you're going to have your tables on the back and have them typed. So to go on Desmos and Planet, if you open up Desmos, it's going to look like this, which is awesome, but not super helpful when it comes to polars. So to get the polar graph up here, you click on the little wrench, and you switch your grid to that one. It defaults you to this. So it's gonna look like this. And then over here when you're typing your equation, just make sure to include the R equals. You can put in any polar that you want. The keyboard has in our ABCs, it has the theta in here as well. So you can do your R equals, and you can have your theta if you want to see the spiral. You could change the number on that. You could do theta times, 5. And I'll make, that's not the right thing. There we go. Making a big spiral. You could do 0.25, making a very small spiral. You could bring this in and do sine is in the trig function. So there's a little circle. We could grab a little flower. But you can make your plan this way on what pieces you want to include. And if you want to include more, since you want to do more than one equation, you can do separate lines. And do our R equals. And as long as you put in your R equals, it'll be fine for your, hang on, here's number 6. 2 cosine of, and in the ABCs is where we have our theta. You can also just type in, if you have theta, and it'll switch it. And you can do, I don't know. What's up? I haven't gotten there yet.
Is this one gonna be on our final?
So you can set up your pieces like this, and you can play with them and make your design the way you want it to be. The points for each of them are listed here. So roses are worth 7 points, circles are worth 3. Circles are a lot easier to make. So you can get up to, what is it? You can select 25 points that I'll give you for it. It's graded out of 30, so 5 points here, 5 points here. If you do 25 here, that's 5 points extra.
Ooh.
So you need to do at least 4 graphs, no less than 4. You can, I'll just say, you can do as many as you want, but I'm only grading 6 of them, and you can get no more than 25 points on here. So if you do 6 flowers, that is a lot of, that's 42 points, but I'm not grading you more than 25.
Okay, but
Quiz. It goes into the quiz category. Okay, so you guys can plan your pictures this way and use this to kind of help you build out tables. Tomorrow I'll start getting out all the supplies. I have a graph for you guys that goes out to, let me double check, I think it goes out to radius 6, so don't go farther than that. So don't have your radius be bigger than 6, wrong word. What's up? I was make sure it meets your qualifications, but yeah. 1, 2, 3, 4, 5, 6. Yes, I have a radius of 6 on our graph. Okay, and I have string of different colors. You guys can do all kinds of designs, do whatever you want to make it pretty. You guys can play with the Desmos graphs. I was gonna say there's lots of different options. So that would be
Miss
figure out your shape. And your shape is
I'll do it tonight.
No. So that would be number cosine, number theta. So yeah, you guys go like a flat rate.
As in week? Oh, week. As in not tomorrow.
So it's
As in not the day before.
the project is out of 3 cans, but that still only counts as 1. That's one equation. That's one graph.
Oh, I thought you said
Just gotta do next week.
No, that's one graph. You gotta do at least 4. So.
SBSG.
What's that?
for where it says graph one, like for like where it says the graphs, do we put the equation here or we just put
Yeah,
the
we're gonna have the equations there so that you can match up which one it is, and I can know which color string I'm going over there. Because you're gonna do different colored string for every one of these.
So how do we,
Yep.
how do we put the name, the equation itself?
So as far as like on here, I'm not as concerned about it. I want like when we fill in the tables, you're gonna put the equations in it. You're gonna put your equation, you're gonna fill in the table, and y'all are gonna type it. And then you're gonna plot your points, and we're gonna connect them with the string. So you're gonna have your equations, you don't have to necessarily fill anything out on that. I'm gonna use that to grade things. So you're gonna fill in tables, we're gonna plot up points. If you wanna use that as your structure for how to use it as we need to, totally fine. I have a million copies of that, I use my own preferred grading things. So mark all over that, all you want, I don't really care. But we're just gonna get, and these four graphs, to get the number of points we wanna have.
I wanna do
These
this
four
one.
is, yeah, this.
And then, what is one?
These are the equations, r equals 0.5 theta, r equals minus 0.5 theta. So that you can use spirals.
And then,
And then here, and rows. It's totally fine. Because I gave them pink flower, black flower, blue spiral, green spiral. And we got all our points there. Okay?
we can do it just a circle. And then I'm gonna do a row.
At least 5 graphs.
You need to get at least 4, and you wanna get to 20 points. I will give you up to 25. So if you do, like, 5 circles, that gets you 50 points. Otherwise you can't do circles.
Okay, I'll do them.
You just wanna get somewhere between 20 and 25 points. If I look at the reverse, you're gonna do 5 points, and I go and grade it out of 30.
We will do.
I will need up to 25 points here, which will get up to 25.
Oh, amazing.
Okay? So we're just trying to get, you need at least
So
4
we
graphs.
have 7 points.
But however many points that is up to you. If you wanna do more, you can do as many as you want. I'm just gonna grade this, because otherwise people are like, oh, circle, 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 circle. Like, I didn't know that. Gotta get it.
Oh.
Okay, so we're gonna work on this a bunch over the next few days. I'm gonna say preliminarily, this is gonna be due on Tuesday. If we need to fudge that, we can. And I will get you guys final exam review tomorrow, so that you guys have it for over the weekend. So you guys can start looking at planning your project today. We'll start working on the project tomorrow, and I'll get you guys the review, so we can start working on that before next week.
Wait, do you have any, like, any for inspiration?
There's the blue one up there, there's the green one over there. I have. Just don't pick them up because they're very stabby out the back. Because they've got smushed, so these pins are all stabbing through the backside. Especially on the spot. They're very long on the back. So several, they're different. That one's very stabby. So like, this one has, we've got a spiral here, spiral of Archimedes. We've got a infinity right there, so that gives us one of our Archimedes, and these are all their tables here. So these are the, oh, we got one here on the orange. And then we got our